Okay, let me ask a couple of things before we go with. My plan for today is to see if you have any questions about looping, and that's my question. Any questions about looping? About assignment 5? No, you guys know how to do loops. You have done assignment 5, it's super easy, right?
Working on it.
Cool. Then I wanted to cover the solutions to assignment 4 and kind of discuss, right, and help with that stuff. Actually, let me do this. We should be able to just do it, right? Don't save anything. Source main Java assignment 4.java. The first thing for the assignment was read within range, right? We are getting a scanner, a print screen, and low and high, right? So, and we need to recursively keep asking the user until they give us a number between low and high, right? So something like this. We need to ask the user, we probably want to print something, right? Where? Sorry? Printleton. Okay. Thank you. Number or something like that equals int dot next int. Right, we get the number, read number from the user. If the number is between high and low, so number greater than or equal to low and number less than or equal to high, return number, else print sorry number and then here's the recursive call, right? What do we return? We just call the exact same function, right? Which will do the exact same thing and eventually give us a number between low and high, hopefully, right? And so hopefully this will actually compile. If we try it with grade, we should now get 25 points out of 100. Woohoo! Ah! Except if we keep making typos. Cool, right? Any questions on this one? No? String times is even easier, right? It's basically the same thing as power, but concatenating strings instead of multiplying, right? So basically, if times is 0, we need to return the empty string, else return the string concatenated with string times of the string and n minus 1, right? And since we are going times minus 1, sorry. Since we are going down, eventually we should reach 0, return the empty string, and it will all be built, right? This is the right way to do things in this class. It is not necessarily the best way to do things in Java. I don't want to overload your brain yet. And normally it doesn't terribly matter. Normally this is okay. But every string concatenation actually creates a new string object, right? And so in here we would end up with, even though Java garbage collects those objects and they disappear from memory and eventually return to memory, we would have 10 partial strings being created. Does that make sense? Which is kind of bad for our memory usage. Do we care if we do 10? No. Do we care if we do 10,000? Maybe. Do we care if this is inside a loop that's executed 1,000,000 times? Probably, right? And so if you are interested and want to play with that, there is a class called String Builder that is a mutable string. Strings in Java are immutable. You cannot do things to them. You can do things with them, but you can never change them. And so that makes it slightly inefficient, plus recursion in Java is slightly inefficient. But on the other hand, it works and it's incredibly simple to understand, right? We have is prime. It takes a number n and a number to test or last tested. When I explain it, I usually end up with current number to test or something like that. We want to do it. What did you guys end up doing? Using mostly current number to test or last tested? What did you pass? Last tested? Really? So if you pass the last number tested, right? When do you, and actually what we need to do, right, is test every number between 2, initially between 2 and n minus 1, right? And see if it divides the number n. If it divides the number n, then n is not prime. If it doesn't divide the number n, then n is prime, right? The very simple, straightforward way is doing every number between 2 and n minus 1, right? How do we stop? When do we, how do we want to go? Do we want to go up or down? Yes. Down? So we are going to start at n minus 1 and go down, right? Actually, if we are passing last tested, right? Then we really need to do something like that. Int number to test equals last tested minus 1, right? That was the last number tested. So we need to test the next one, which is, we are going down. If, let's see, if the number to test ends up being 1, right? And given that I'm paranoid, I do less than or equal, what do we know, right? If you tested number 2, it wasn't divisible by 2, you go now to test number 1, what do you know? You are done and it is prime, right? So we can do we already know, so return true. Now, if it divides and modulo last tested is 0, right? Sorry, not last tested, number to test. Then what do we know?
I thought 1 couldn't be prime.
Sorry?
I said I thought 1 couldn't be prime.
1 is not prime. Oh, yes. Yes, but we are going to cheat later. Yeah. 1 is not prime and 2 is prime. But if the number divides, right, number to test divides n, then we know that it's not prime, right? And if not, we return is prime of n number to test, right? Which is the number that we just tested, right? Does that make some sense? It's probably not how you wrote it, but.
Why do you need that second parameter? Why do you not use like n minus 1?
Because it's not n minus 1. It's going to start being n minus 1, then it's going to be n minus 2, then n minus 3, n minus 4. I'm using number to test, which is last tested minus 1, right? So when you call it initially, you call it with n as last tested.
Yeah.
So I say number to test is n minus 1, right?
Mm-hmm.
Check. Is it less than or equal to 1? No. Does it divide n? Probably not. Then I'm going to call is prime again with n, but now I'm passing n minus 2. Or sorry, n minus 1 as last tested, rather than n.
Yeah, but you could pass n minus 1 and use just 1.
But I just tested n minus, I just tested n minus 1, then I'm going to test n minus 2, then I'm going to test n minus 3.
Yeah, but let's say that n is 3. N minus 1 is 2.
Yes.
So when you're returning, you're going to be passing 2.
Yes.
So when it calls the method again, 2 minus 1 is going to be 1.
Yes.
So.
And then eventually that 1 is going to return true.
Yeah, but I mean, I still didn't get the point of the second parameter because you're going to be passing n minus 1 at the end call anyway.
Not n minus 1. I'm going to pass last tested minus 1, which is not n. N is always 3, right? If n is 3, I'm going to be passing, the way that I wrote it, right? I'm going to pass 3, 2,
3, 1.
and 1 as last tested. 3 and 2 as last tested, right?
Okay. I see what you're saying.
Yeah, so n is still going to be 3, but the other parameter is going to come down, because that's which one I need to test.
I got it now. Thank you.
That's why you need the second one.
Yeah.
If you think about it in terms of loop, is your looping variable. Is your I in your loops. This appears like it will work, right? And when I pass it, I started with n, right? When I start, I pass n and n, and that would work, right? Maybe. And I think I wasn't evil in my tests. Yeah, it wasn't evil, right? So I'm actually not testing 1. But how do we make sure that the problem with this is that if I call is prime of 1, right? We'll call is prime 1 on 1 and it will return true, right? Which is not terribly wrong, right? It would be a perfectly reasonable assumption in math, except that by convention, not by definition, right? But by convention, 1 is not prime. Why go ask mathematicians, not me? It's just a definitional thing, right? So how can we fix it? That's kind of a special case, and that's okay to do it in the wrapper, right?
So why couldn't you do that in the...
You can, but if you do it in the recursive thing, first of all, that recursive function is already complicated in a way, so you're adding more complexity there. But also, it's going to be done 10 times. If you call it with 10, then it's going to check whether n is 1 10 times instead of 1. So it's better to do it in the wrapper. You could do it in the recursive function. It's just better to do it in the wrapper. Does this make sense? There is a couple of other things we can do, right? One, actually, one easy, actually, let's do a couple of things. Let's start playing with this one. An easy one is instead of passing the last number tested, pass the number to test, right? And so we don't need to do this, we just do this, and then here we pass number to test minus 1 as the one to test later, right? And here we would start with n minus 1. And that should work. Makes this good, right? So that's okay. There is an optimization that we can do, which is when you have factors, right? You know that one is going to be less than the square root of n, and the other one is going to be bigger than the square root of n. Does that make sense? If you have the number, okay, let me write it here. That way it's on the video. If you have the number, say 65, right? Or 60, which has a ton of factors, right? Square root of 60 is what? Is between 7 and 8, right? But what happens, what are the factors? We have 2, right? When you divide by 2, what happens is you're going to have 30 on the other end, right? Then your next factor is going to be 3, and the corresponding thing is 20 on the high end, right? Then the next one is 4, and you have 15. Does this make sense? For every factor, the other factor is, right? One is big, the other one is going to be small, right? And they're going towards the middle, and so our last factor, I think we have 5 and 12, and then 6 and 10. And we have this divide, which is the square root of the number, right? And so one of them has to be, other than the square root, which would be, right, kind of a degenerate factor in this formulation, right? One of them has to be below and one of them has to be above, right? Because of how division works. And so one way to optimize this by knowing math, right, which is not a requirement for this class, but it's by knowing your domain, and in this case, your problem domain, your domain is math, is rather than passing n minus 1, use square root of n, math.sqrt. t of n. You don't really need to start from n, you can start from the square root of n. For large numbers, that makes a big difference, right? And hopefully it works. We are actually, it died. Possibly lost conversion, of course. Java is nice, and it tells us you're trying to go from a double to an int, so you are losing the decimal part, which is actually what we want, right? For 60, the square root is 7.5 or something like that. We don't care about the half. We actually want only the 7 because of how we are starting this way, right? And so that would work. But we need to tell Java that we explicitly, yes, I meant an int. I am not an idiot. Or at least I'm not wrong in this particular way. Does that make sense? So if you do this, your program would run incredibly faster. It doesn't terribly matter. We were playing with 5 numbers, right? But some of you actually came up with a really cool optimization that I hadn't thought about. Which was, if you're counting up, they treated 2 as a special case, and then they started at 3 rather than at 2. But if you do that, you only need to count the odd numbers. So they started going, so you test 2 first, and then you don't really need to test 4, because if it's divisible by 4, it was divisible by 2. If it's divisible by 6, it was divisible by 2. So they'll do 3, 5, 7, 9, 11, which I thought was cool. This optimization is more useful because it reduces the order. The other one is just a constant factor, but it's still twice as fast. So twice as fast is pretty good. Print FizzBuzz, in which it was an interesting thing. People who know how to call functions, right, takes about 10 seconds to do this one, right? How do you do this one? All I need to do is generate all those numbers from to to, right? In starting at from, right? And then print that stuff. So I just do if from is greater than 2, return. Otherwise, print, so out.println. I'm going to print from, but not from. I'm going to print FizzBuzz of from. There's already a function here that converts it, right? And then call print FizzBuzz again with from +1 to and out. Does this make sense? Even if I hadn't given you the function, this is probably the right way to do it, right? Because you want to try to make stuff simple, right? You want to build your pieces so that the code ends up being incredibly simple like this. You're just counting, right? Many of you actually added all the if statements and things like that over there. It works, right? But this is incredibly simple. And it's actually the purpose of this. To kind of remind you that you should build simple functions and call them. Any other questions about recursion at all? No? You're good? You understand recursion? You understand loops? you're getting used to the highs and lows of programming. Sometimes some things should be challenging. It is okay to fail because you can fix it. You get immediate feedback and you fix it, right? One of the really good things, there are many bad things from the people side about being a programmer, but one of the good things is that you don't need to be right the whole time because you're wrong 100 times a day, right? You mess up and you don't type a semicolon, the compiler yells at you. It's normal. You just fail 20 times a day. It is what it is. Questions, comments? No. Let me then point out that there is now, God, and I haven't added it there. I suck. I will add it here, politician's promise. There is a module M for the midterm that includes a review paper, solutions, and actually a midterm from spring, maybe. So you can go look at kind of what kinds of questions and what does the midterm look like. It is a sample, not a guarantee, right? Don't memorize the test, right? This is just to kind of give you an idea. Also, I like to do this kind of stuff when I start teaching the same course over and over to keep me honest, because now there is no advantage for you to having access to an old test. I give you access to old tests, and I will start putting them all. That forces me to come up with new questions rather than reuse the same ones, and then it becomes easy to pass the class without learning. The right way to study for this is to learn how to program, and then the test is incredibly easy and you just ace it. That's one thing you would notice is I usually give a few extra points, like this one was over 110. Usually make these kinds of tests over like 105 or 110, because I'm assuming that even if you know how to program, you're gonna forget a semicolon somewhere, right? Also, the midterm is not on the computer, it's on paper. So chances are that if you actually forget a semicolon, I will not even notice, right? But if you forget, sometimes you forget something important, right? And I'm assuming that even if you know what you're doing, you're gonna mess up something. But it gives you the chance to make up to 110 points. Or something like that. It doesn't, again, it's not a guarantee that it will be 110. The plan for the midterm is to be on Wednesday a week from today. Any questions? Any comments? No? Any answers? Sorry? No. Midterm is Wednesday a week from today, which is not October 7th, it's September 28th? Yes. Just a reminder, and this actually works for all your classes if you're taking any more classes. October the 5th is the last day to drop with a grade of W, right? We have a very small period at the beginning of the semester, it's usually a week, where basically you can drop and never be enrolled in class, right? You dropped and you were never here, right? That's only about a week. After that, we got your money, you were here. If you drop the class by the middle of the semester, And if you're taking any weird semesters, it's the middle of the semester. If you're taking the regular thing, for us, it is October the 5th, which is actually the midpoint of the semester. The registrar calculates that stuff. You can drop the class and get a grade of W in your transcript. It does not count towards your GPA. It still appears on your transcript, but it doesn't count towards your GPA. It does count towards attempted credit hours and things like that if any of you is getting financial assistance. So it's not a good thing to do, right? The right thing to do is ace the test and get A's in all your classes. But just in case life happens, October 5th is the last day to drop. And usually this tends to be a good option for people who took too much and are trying to take 2 classes and get a full-time job or something like that. And like, no, that's just not going to work. And so just remember that October 5th is that date. I'm not assuming that any of you is in that situation, but I have no clue what you're doing. Sometimes I have no clue what I'm doing. I think that is it as far as lecture. If you want to work on your project and ask questions, I will stay here. Let me turn off. Is it like a particular to your project question? Then let me turn off this thingy.